We are presenting lead ingestion by Morning Doves in South Georgia. I'm Tyler Mercer, and this is Riley Downs. Our mentoring professor is Dr. Jason Scott here at Abraham Baldwin Agriculture College in the spring of 2025. So, an introduction to morning doves, native Macrua. Morning doves are gramivores, meaning they feed on seeds and grains. Doves feed on the soil surface, and due to their weak throat structure, they cannot scratch into the soil column. Females lay 2 eggs per clutch, which is 2 eggs at a time. They lay 4 to 6 clutches per year. And morning doves are a native migratory game bird species that are widely distributed throughout North America. In 2023, U.S. Fish and Wildlife estimated that 88.5 million doves currently are distributed throughout the eastern United States. So, an introduction to hunting management and lead introduction. Dove hunting is extremely popular in the United States. It is the most harvested migratory game bird. In 2023, approximately 400,000 hunters spent 1.2 million days in field just in the eastern United States. Doves are hunted with shotguns using lead pellet ammunition. In Georgia, only size number 2 lead shot can be legally used. The management for doves involves planting food plots. These food plots are used for hunter opportunities and attraction, and usually are cultivated with seeds and grains that are found in the morning dove diet. Hunting over these food plots introduces excess pellets onto the soil. These excess pellets often resemble the same size, shape, and color of the seeds that are used within the food plots. And high hunter concentrations can lead to significant lead deposition and increases on these dove fields. So, for example, on your left, there is number 8 size lead shot, which is commonly used here to hunt doves with here in Georgia. Our middle slide includes seeds that are used for food plots, like sunflower, brown top millet, sorghum, and wheat. And then on the far right side, we have the shot intermixed with the seed. And as you can see, it is easily mixed onto the soil column and indistinguishable.
So, a little historical context about this. Previous studies have shown that 6.5% of wild doves have ingested lead in feeding trials. In captive studies, it's also shown that doves will freely ingest lead in feeding trials. And within these trials, there was these trials simulate natural settings and had no limitations such as food availability. Fields managed for doves display heavy lead concentrations from hunting deposition as well. A field in Tennessee showed a 400% increase in lead post-hunting events, while another field in Indiana showed a 640% increase in lead post-hunting events. As far as lead ingestion and health risks go, doves that ingest lead have a higher risk of health issues, including damage to reproductive functions, circulatory systems, and kidney functions. Ingesting lead can also have damage to things such as the nervous system, mobility, and the immune system. This is a good cause for increased vulnerability for things such as disease and predation. Due to bioaccumulation of lead in blood, bone, and muscle tissue, lead concentrations persist long after initial ingestion occurs. These effects and health risks may cause population declines and pose concerns for morning dove management in the future. So, our study goals and objectives. Our goal of this study is to observe the level of lead ingestion in morning doves within South Georgia. Our objectives for this are to determine ingestion through inspection of the crop or gizzard organs, observe lead ingestion across different conditional factors, these conditional factors being seasonality, sex and age, and management strategies. Our last objective is to observe metallic lead amounts within fields managed for morning doves. For our statistical analysis, we hypothesized for our lead ingestion that early season dove samples ingest lead more frequently than late season samples. To test this, we used a chi-square with an alpha level of 0.05. As far as our soil analysis goes, we hypothesized that soils of main dove fields contain more lead than soils of adjacent areas around the respective fields. We used a one-tailed t-test and used with an alpha level of 0.05.
So, for information about our study area, we use 4 fields in South Georgia for sampling. We have Albany Nursery WMA, which is located in Garden County, Georgia. Then we have Lappaha River WMA, which is located in Urban County, Georgia. And then we use 2 private agricultural fields, which are located in Turner County, Georgia. These fields differ in management practices, the crop that was planted for the year, and the acres that was planted, as you can see in our lower table. Crops planted vary between wheat, sunflower, groundtop millet, and then the 2 peanut fields. And our management types vary between no-till, mowed, burned, versus strip-till, harvest, and bale. These fields all have an annual hunting use and approximately been hunted for 25 years, with the exception of Lappaha River WMA. Lappaha River WMA was acquired by the state of Georgia in 2016 and first implemented dove management in 2017. This gives us an approximate 8 years of annual use. So for our field collection methods, we sampled hunter harvested doves on September 7th of 2024, which is the opening day for the dove season this year. We sampled at Lappaha River and Albany Nursery WMA. As you can see pictured, that is our collection station at Albany River, or Albany Nursery WMA. These samples taken on September 7th are redeemed the early season samples. We sampled again on January 7th and January 9th of 2025 at the Turner County private fields, and these samples were designated as the late season samples. We asked hunters to participate in our study and gave regarding information about our study project and our goals and observations that we wanted to do and our methodology behind it. We asked them to donate their doves, and in return we would process their doves for them, return their dove or the breast meat back to them. And then from there, the remaining carcass was bagged and labeled by seasonality and date and frozen for future dissections. Continuing on to our dissections and our lab work, our necropsy dissections were conducted in the Yale Wildlife and Forestry Building here at the ABAC Tiffin campus. Before dissections occurred, we sex and age every individual and assign them a number. And from there, any crops and gizzards that were penetrated by hunter shot were considered null and void, that in order that way we didn't record any false positives. From there, the contents of the crops and the gizzards were extracted and observed. We placed the contents on fine mesh seals and metal trays, as you can see pictured, to facilitate inspection. From there, pellets were ID'd by magnetism, hardness, and size comparison, and if presence of lead was indeed in the organs, it was reported along with the number of shot in those organs. All sample contents were stored in labeled plastic containers, which was by seasonality, date, and location for a future dietary study. And then in our soil sampling, WMA fields were able to be sampled before the season opened and after the season closed. In the Turner County fields, we were only able to sample after the season closed. Our sampling procedure was consistent across all settings, following the S2 analysis for soil sampling protocol by the UGA Extension Office and Soil Analysis Lab. One soil sample of adjacent areas was taken around each of the 4 fields, and this was used for a mean comparison between the content of lead within the main dove field and the surrounding areas.
So our result for the ingested lead, we collected a total of 339 doves across all 4 sample fields. We had 7.82% of these 339 doves had ingested lead. This was plus or minus 4.71%. That includes our 95% confidence interval. Within these 339 doves, juvenile doves ingested lead 1.63 times more frequently than adult doves did. Within the adult subset, males ingested lead 1.75 times more frequently than females. And if you'll see here, we have our tables with the number of samples from each field, the number of shots found from each field, and then the number of doves on the far right that had pellets within them. In the picture here, these little gray looking dots in this bag, those are actually lead pellets that came from a dove from a Lappaha River WMA. It was a juvenile and it had 13 pellets within its gizzard. So here's our results in graph form. You see here, we have all of our sample fields on the x-axis and the percentage of ingestion on the y. Lappaha River had 8.1% ingestion rate. Albany Nursery was 9.9. Turnerfield A was 3.6. Turnerfield B, 9.8. This graph on the right here, we have our 4 fields, and this is our lead ingestion compared to age class, so juveniles compared to adults. For our chi-square test that we ran, we had a p-value of 0.417, which was greater than our alpha value of 0.05. Therefore, we failed to reject the null hypothesis, meaning that there is no significant difference in ingestion based on seasonality. You can see that graph here as well. For our soil analysis, our main fields had an average of 0.984 pounds of lead per acre. Our adjacent areas had an average of 0.819 pounds of lead per acre. Our T-calculated value was 1.189 with a p-value of 0.16, meaning that there is no significant difference when p is less than 0.05.
So for our discussions, our results indicate that when fields have been historically hunted over, residual lead deposition occurs and can be ingested by mourning doves. Our results are slightly elevated from the previous study's range that display of 1.1 to 6.5% of ingestion in wild mourning doves. Our results indicate the presence of lead, albeit no difference between the main fields and the adjacent areas. Further study and observations are needed for more accurate estimations of ingestion. It calls into question if necropsy is the best method for determining lead ingestion. A 1979 study showed that there was rapid erosion of pellets within the gizzard, and that 75% of a 412 bird sample showed muscular lead content with or without the presence of shot in the gizzard. This topic warrants attention and is important to mourning dove management considering the health implications. This is a species of birds that lays 12 eggs per year max. Previous studies have shown that chronic lead exposure in females reduces hatching success by up to 50%. Considering again that this is the most harvested game bird species and a very popular species to hunt, it calls into question population declines, distribution fragmentation, and human health implications to the ingestion. So attention needs to be placed onto this topic for full understanding.
For our management applications, previous studies have shown disking the soil can reduce lead density in the topsoil column post-hunting events. However, a study in 2017 showed that fields with historical hunting use of about 26 years had no effect reducing lead in the soil when disked. Manipulating vegetation areas where doves prefer to feed may be effective as well. As you can see in the picture here, this is our Turner County Field B the morning of the hunt when we collected our sample. As you see, it's mostly bare soil, and it had the second highest ingestion rate of our 4 fields with a staggering 9.8%. Vegetation height has been shown to influence the use of feeding areas for doves. A 1996 study showed that doves prefer vegetation of 2 centimeter height over bare ground.
We would like to acknowledge and thank Dr. Jason Scott, Dr. Wallace Woods, Dr. David Gray, Mr. Philip Ford, and the entire ABAC Department of Forestry and Natural Resources. We'd also like to thank Mr. Brent Howes and Seth Thompson of the Georgia Department of Natural Resources. They were critical in allowing us access to these WMAs and giving us advice on hunter participation, methodology of the study, etc. We'd also like to thank the private landowners of Turner County. They were crucial for allowing us to gain adequate sample sizes in the late seasons. Thank you. Listen to our presentation. Any questions? That 2 centimeter area, which was preferred over bare ground or mowed areas, having that high or that 2 centimeter high can negate lead ingestion by reducing the visibility of it on the bare ground. That's the point I'm trying to make, is that lead shot stays on top of the soil and it's very visible. If you have that 2 centimeter covering, it's not as visible to the doves and can be dispersed by that vegetation.
So as a preventative measure?
Correct.
Yes, sir.
Okay.
Without going through iCook and getting an adequate sample of more than 50, which is what we felt was the kind of the limit in order to get a sample size that showed effective ingestion, I don't think so. There's been studies that have done tracking on these fields and not using hunter kill harvest, but we didn't have time for that, and it just wasn't happening for this project.
I mean, obviously this data is a lot easier to get too.
Yes,
sir. That's the reason you're there, so.
Gotcha.
And as far as like capturing birds that have never been hunted per se, as much as those move and as popular as it is in the southeast, which is where we would be doing it obviously, tremendously. And the number of dove fields there are now, like it's growing every year. You see more and more fields. It's going to be nearly impossible to find a dove that has not been shot at.
On top of seasons being different throughout the states. The same season dates in Georgia are not the same in Tennessee and so forth. Interestingly, we found a dove from Albany Nursery that ingested a .77 copper BB that you find like in a Red Rider. It was really neat. So there were some limitations to the study design. We visited 4 WMAs in the early season during September, that being Albany Nursery, Lap Hall River WMA, Chickasaw Hatchie, and Elmerdale. After September 7th, which was opening day, hunter participation dropped off dramatically. During these revisits, there were no hunters to participate in the study. We could not get an adequate sample size just by the 1 or 2 hunters that were there. So, we decided to go with the private fields that had definitive shoots with a number of hunters that could get us that adequate sample size of 50 plus. In the turtle fields, we had 83 and 92 compared to even the Lap Hall River, we only looked at 62 birds, and that was the low, and that was the opening day. So, tell you where you can get it, move along, adapt, overcome. I think you would have to have biologists, multiple biologists across multiple WMAs, and then possibly setting up organized hunts that are to gain the proper adequate sample size. And even then, I don't know if it would be possible to gain that 50 plus.
Yeah, on the WMAs in the late season, it would probably take just repeated days and days and days going out and hoping that somebody comes up and kills some birds.
And even with the structure of the dates, there are monthly gaps. So it opens up September, closes, opens up in October, closes, and then opens up at the tail end of November. So getting that seasonality within those time frames and hunter participation, maybe possibly there. Yeah.
Okay.
That's what your hatching success, your embryo mortality is increased because it passes on from the female to the egg itself.
That could be problematic.
Good.